Hello! Joining us today is Ed Syrocki, owner of EMS Classic Cars, located just outside of Detroit. Ed is a 40-year veteran mechanic and auto enthusiast, and as the name of his shop suggests, he only works on classic cars. Ed has been lending a hand to the HVA in our joint efforts to educate classic car owners about ethanol in our gas. Today, Ed is going to walk us through, based on his experience in his shop, what type of damage ethanol blended fuel can do to our classic car engines.
Hi, my name's Ed from EMS Classic Car in Warren, Michigan, and I'd like to show you some problems that I have with classic cars and the components that go into them from ethanol. We've got problems with carburation on ethanol, corrosion that causes a problem around the carburetor, the accelerator pump that's mounted in the bore after sitting for periods of time. That corrosion causes the accelerator pump to stick in the bore. You open the throttle up, the accelerator pump jams down into the bore. Won't release the throttle back, throttle's stuck, and when you pull it apart, you ruin the accelerator pump. For carburation, you've got passageways in the fuel block that allow fuel through. You've got small ports that the varnish from the gas tank gets caught into, or the ethanol causes a corrosion in the passageway and then ruins the fuel block itself. Also, the power valves that are in those fuel blocks, the rubber diaphragm that's in there, it's ruined from the ethanol, hardens it or ruptures it, which causes a flooding condition or hesitation or stumbling on acceleration. Other components that are in carburetors are different style of accelerator pumps. Just because you've got a plunger doesn't mean that it's going to be hurt. You've got 4-barrel accelerator diaphragms that are on the back of the 4-barrel that the diaphragm can rupture and or harden up so that you don't get a 4-barrel action on it. Accelerator pumps on other carburetors that have a diaphragm that have to be pushed and pulled can cause it to stick in or seize up, all hardening from ethanol. Floats that burn on the top, not physically burn with fire, but the alcohol or ethanol as it evaporates off takes and leaves it porous, it sinks, causing a flooding condition. Needle and seats on a carburetor, the needle is made out of a rubber tip. The rubber tip goes into the hole. The tip seals the hole, which stops the fuel from going through at a specified level where the float level is at, and that can allow fuel to leak around, which causes a flooding condition. You've got choke pull-offs, which operate when the cars first started to open the choke a specified amount for the right air-fuel control mixture, and the diaphragm that's in there can be affected because the hose is connected to a port in the carburetor that allows the vapors of the ethanol to go through it. You've got the diaphragm that's in vacuum advances on a distributor, that the diaphragm can get hardened or rupture, causing poor performance, low fuel economy. We'll go to mechanical fuel pumps. Most of the old cars have mechanical of some sort. Dual diaphragm mechanical pump. This fuel pump sat with fuel in it on a car, not outside, in a building, in storage, and the ethanol corroded away the inside component where the fuel was sitting as it evaporated off and left its corrosive properties and allowed it to chew the pot metal of this fuel pump so that it could not be repaired, so it had to be replaced. Other fuel pumps with the same diaphragm issues that we have with carburetions, you've got diaphragms and check valves inside of a fuel pump. That diaphragm can be either ruptured and or stiffened to stop the fuel pump from operating. You've got a good example here of a fuel pump that the diaphragm is hardened up and you cannot push the diaphragm down in because of the hardening of the diaphragm itself. You've got the inside portions of a fuel pump, the check valves, the inlet and outlet check valves that get a corrosion, a white powder corrosion that come in because of the ethanol properties and what it's doing. As it evaporates off, it leaves these powders, and that residue builds up on top of these valves till the valves stop operating. Makes it unpredictable on whether the fuel pump's going to keep going or if it just suddenly stops working on you. You've got other rubber components that are in fuel pumps that cause exactly the same problem. The rubber is turned to mush or jello, very stretchable, pliable, and as soon as you take it out and allow it to lay on a bench for a period of time, that same rubber component takes and shrinks and turns hard, so it's not a viable product anymore. You've got problems with electric fuel pumps, whether the diaphragm style or the jet pump style, is that the diaphragm on this one will go bad. The same way a mechanical fuel pump will go bad. On the jet pumps, the spinning action or the vane style, that will seize the shaft onto the rubber components that seal it and stop the pump from turning. So it's fuel pumps. Here you see an example of a ethanol testing device. Simple, add water, add fuel to the top line, tells you how much ethanol is located or is in that fuel. At this one it's showing about 7% of ethanol, which we do on every one of the cars that come in with a runnability problem. Otherwise, we have no idea where we're starting on the cars. This is a inlet hose. The rubber hose would show deterioration from age on the outside, but what we see is that this rubber hose on the inside has deterioration and rotted, which softened it up, and then it turned around and turned into basically a rock. It's hard as a rock. It's not flexible anymore like rubber. Gasoline in the previous years, I never seen this condition happen before. We've got hoses that supply fuel up to the fuel pump. On the inside of this hose, when you look at the outside deterioration, this looks like age, but what's happened here is that the fuel is seeping through and softening the inside hose, and as it does that, it gets through the pores, comes through the outside, gets to the outside of the hose, and then destroys it. If you notice that this would normally be a very pliable hose, the hose is turned really stiff. Fuel filters that we pull out with sediment from gas tanks, normal rust contact and sediment. What we have here is along with rust, we also have water contamination with a combination of it. In the gas tank itself, you've got a float that controls the fuel gauge inside the car. So we're finding that some of the materials for the ethanol is causing the floats to eat away or burn away, as they did in the float for the carburetors, being exposed to the air, since they don't sit completely in gasoline or the fuel completely submerged. A good example of a cork float, which a lot of older vehicles use, are shellacked floats, cork with shellac over the top of them. Here's one that's has the shellac still on it. Here is a float that the shellac has been completely removed from the ethanol. You would think it had been in there for a long time and it's just old, but actually ethanol did that. It's not a very old float. Other hoses that we see in gas are the fuel supply hoses coming off. This is normally 5/16 fuel hose. It's normally very pliable. If you notice, it doesn't bend very well. It's pretty rigid. Basically, the ethanol, as it passes through, removes the oils that are naturally in the hose, and as the fuel stops running through and the air hits it, it dries the hose out, which then causes it to stiffen, and in some cases, depending on the curve, that will do the same as this hose. That curve will then sit there and crack. Pretty soon this is a rupture condition. This is on the suction side of a fuel pump, which means that there's always gas being drawn into the fuel pump. This would be on the pressure side of a fuel pump. This wouldn't be a problem other than a leak on the ground. If this hose ruptured going up to the carburetor, this hose ruptures, it'll spray fuel everywhere, and then who knows what's going to happen from there. The last thing I've got, older gas tanks have a lot of varnish buildup. They've got a lot of rust and sediment that are in them, and that the ethanol-based gasoline is dissolving that varnish inside the tank, and once it does that, it's pumping it forward through the fuel pumps up to the carburetor and all the way down into the engine chambers, the valves, from the valves and pistons, all the way back to the gas tank. Ethanol just is not working.
For complete information and resources on ethanol and how you can take action, please go to www.historicvehicle.org.